Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the RC-135 Rivet Joint over the Gulf during the opening nights of Operation Desert Storm, and the crews and opponents who gave it its reputation. A longer version with fact sheets and photos is available in the print edition on LinkedIn or by email. You can find more articles, podcasts, and resources at trackpads.com. The cabin lights glow a muted red as the big four-engine jet settles into its orbit over the dark water of the Gulf. Outside, the night sky above Saudi Arabia is streaked with the faint arcs of tankers and strike packages flowing north toward Iraq. But inside this aircraft, windows are almost an afterthought. The crew of the RC-135 Rivet Joint watches the war through headsets and screens instead of glass. On their scopes, green symbols blossom and fade as Iraqi search radars sweep, try to lock, and then blink out when they are jammed or destroyed. One operator calls out a new emitter coming alive near Basra, marking it and beginning the process of pinning its location down within a few hundred meters. Another compares its pattern with known systems, judging whether it is a familiar radar or a surprise. The aircraft banks slightly as it tightens its orbit, engines humming steadily while the mission crew shapes what commanders think they know. Up front, the pilots and navigators keep the Rivet Joint exactly where the mission crew needs it, just outside the range rings of Iraqi surface-to-air missiles, yet close enough to drink in every watt of hostile energy. They watch fuel, headings, and airspace while managing checklists and the steady demands of a long-endurance flight. Far away, strike leaders and air defense commanders listen for the calm voice of a controller on this aircraft relaying what the Rivet Joint hears in real time. For the people who fly and work Rivet Joint, this night over the Gulf is one moment in a chain of long, demanding sorties. Each mission feels like the payoff for decades of design choices and doctrinal arguments about how best to listen to an enemy without ever crossing his border. Earlier generations of crews had spent their careers orbiting off distant coastlines, watching and waiting in much the same way. The RC-135 Rivet Joint exists because modern wars are decided as much in the invisible spectrum as in the visible sky. In the early Cold War, officers in the United States understood that enemy radars, radios, and missile guidance links were as critical to a battle as tanks and bombers. They also knew that their existing ways of collecting that information were fragile. At the same time, the threat picture was getting steadily worse. Long-range surface-to-air missiles, high-performance interceptors, and dense radar networks turned the border region into a lethal environment for any reconnaissance aircraft that tried to hang near the front line. Commanders still needed a detailed map of the enemy's electronic order of battle, a mental picture of where radars were, what frequencies they used, and how they talked to each other. Signals intelligence had usually been done from the ground, from ships, or by small fleets of highly specialized aircraft built in tiny numbers. Ground stations and ships could be powerful, but they were tied to geography and political limits. Small specialized aircraft could gather valuable data, yet they often lacked the range, altitude, and endurance to cover distant theaters for long stretches. None of those approaches could offer global reach, very long time on station, and real-time reporting to both theater and national decision-makers. The answer was to take a proven jet transport and tanker airframe, the C-135 family, and turn it into a dedicated electronic reconnaissance platform. That airframe could already fly high, fast enough, and far, and it could refuel in flight to remain overhead for many hours. Designers and engineers filled the cabin with mission consoles, receivers, processors, and recorders, transforming it into an airborne listening post. The decision to turn the transport and tanker airframe into Rivet Joint meant taking something familiar and deliberately reshaping it around a new mission. Inside that familiar outline, almost everything changed. Space, once used for cargo or fuel, was mapped out as rows of mission consoles and equipment racks, each with to-the-inch planning, so operators had room to work and systems had the cooling and power they needed. Companies that specialized in electronic warfare and signals intelligence equipment adapted their receivers, processors, and recorders to fit the constraints of a pressurized cabin that lived at high altitude and constant vibration. By the early 1970s, a mix of earlier reconnaissance variants that had flown Cold War border patrols and Vietnam missions started to converge into what would become the RC-135V and RC-135W Rivet Joint standard. Airframes originally built as transports or earlier intelligence models cycled through heavy modification programs, emerging with updated engines, improved cockpits, and a common mission suite tuned for theater support. Stepping through the door of a rivet joint feels less like boarding a transport and more like walking into a narrow, humming control room. Up front, the cockpit still looks broadly familiar to anyone used to large jets, with 2 pilots, a navigator station, and panels for engines, fuel, and autopilot. Behind that, the personality of the aircraft changes. The human layout is as carefully engineered as the electronics. A typical sortie brings a cockpit crew of pilots and navigators focused on flying a precise orbit in exactly the right patch of sky. Behind them sits the mission crew, made up of electronic warfare officers, linguists, intelligence specialists, and airborne maintenance personnel. Some of them specialize in finding and classifying radar emissions. Others listen for voice communications or track data links, and still others watch the big picture and direct how all that effort fits together. Each console is its own small world. Operators wear headsets tied into carefully controlled communications nets that let them speak to one another, to supervisors on board, and to command centers or other aircraft beyond the horizon. Their displays show slices of the spectrum, signal strength traces, lists of emitters, and geolocation plots, sometimes overlaid on simplified maps with icons marking hostile systems. Around them, the airframe has been reshaped to support this mission. Antenna arrays along the nose, cheeks, sides, and tail scoop up signals from across the electromagnetic spectrum, feeding them into receivers and processors that can sort, filter, and store a torrent of data. Cooling systems and power distribution hardware work constantly in the background to keep sensitive electronics within their limits in thin, cold air and hot climates alike. Training materials and unit histories emphasize how different the real experience is from the clean diagrams and tidy timelines in a classroom. Long missions mean long hours at a console, with headset fatigue, shifting priorities, and the constant possibility that a quiet orbit will turn into a high-stakes moment if the enemy does something unexpected. Veterans describe the technical challenge of keeping up with agile, adaptive opponents who change frequencies, modes, and procedures as soon as they suspect they are being watched. That relationship between machine and crew becomes most visible when the rivet joint is thrown into a live air campaign. Its first great test under fire did not come out of nowhere. For decades before Operation Desert Storm, RC-135 crews flew the quiet missions of the Cold War, orbiting near the borders of the Soviet Union and its allies, mapping radar sites, listening to command nets, and learning how hostile air defense systems spoke to one another. Operation Desert Storm became a live-fire exam for Rivet Joint. Before the first strikes crossed into Iraq and occupied Kuwait, Rivet Joint orbits had already helped chart the Iraqi Integrated Air Defense System, identifying key early warning radars, fighter control nodes, and surface-to-air missile batteries. As the air campaign opened, RC-135s settled into racetrack patterns over Saudi Arabia and the Gulf, and stayed there. Controllers on board relayed time-sensitive warnings and assessments to airborne command posts and strike leaders, often shaving seconds off reaction times that meant the difference between a clean escape and a missile launch. A short warning about a radar that had just gone live or an unexpected gap in coverage could change a route or confirm that suppression missions had actually done their job. The effect was not as visible as a laser-guided bomb hitting a hardened shelter, but it was just as real. The aircraft's baptism of fire in Desert Storm cemented its status as a central player in modern air campaigns. After the ceasefire, Rivet Joint did not fade into the background. It continued to fly in later operations over the Balkans, where air defense networks and political limits on basing made airborne listening platforms especially valuable. Over time, Rivet Joint became woven into the standard pattern of how the United States prepares for and fights an air war. From the perspective of the crews and commanders who depend on it, the Rivet Joint's greatest strength is its ability to turn the chaos of the electromagnetic spectrum into something human beings can understand and act on. It brings endurance, with the C-135 airframe and aerial refueling allowing missions that stretch into double-digit hours. It offers reach, able to deploy far from home bases and operate from forward locations when required. That human integration is part of the design. There are real trade-offs. The aircraft's size and value make it a high-profile asset, and no one wants to risk an RC-135 deep inside heavily defended airspace. It usually works from standoff distances, relying on altitude, antenna positioning, and clever signal processing to hear into hostile territory. The high crew count and complex mission systems also demand intensive training and maintenance. Keeping operators current on changing enemy tactics, new signal types, and upgraded equipment is not a one-time event. It is an ongoing effort. Adversaries do not stand still in the face of this kind of capability. Enemy forces practice emission control, turning radars on only briefly, or shifting to passive systems that listen rather than broadcast to reduce what Rivet Joint can hear. They experiment with deceptive techniques, false emitters, and rapidly changing communication methods to clutter the spectrum and force analysts to work harder. These countermeasures do not erase Rivet Joint's value, but they change the shape of the problem. In this sense, the jet is a platform and a process rather than a simple machine. The metal and wiring provide the reach and the ears, but the real edge comes from operators who understand both their own systems and the habits of the opponents they are listening to. The Rivet Joint becomes most effective when its human and technical sides pull together. The RC-135V and RC-135W Rivet Joint belong to a larger family tree of specialized C-135 variants that have evolved alongside changes in technology and threat environments. Earlier members of the family carried cameras, special radars, or instrumentation to support missile tests and research. It was meant to be present where wars were actually being fought. Within the Rivet Joint community, upgrades have been steady rather than dramatic. New generations of receivers, processors, and operator consoles arrive in incremental blocks, each bringing better sensitivity, more automation, and more intuitive displays. What began as racks of largely analog equipment feeding tape recorders has shifted into digital systems that can handle many more signals at once, sort them faster, and present them in ways that help humans make decisions. International cooperation has played its part in Rivet Joint's evolution. The United States has worked with close allies to share capabilities, training, and in some cases, aircraft themselves, extending the reach of this type of platform across multiple theaters. Lessons from each conflict and major exercise feed back into software updates, equipment refreshes, and refinements to tactics and procedures. Decades after the first C-135 airframes left the factory, Rivet Joint remains a central pillar of how the United States approaches air operations in contested environments. Its legacy is visible not just in its own missions, but in the way doctrine casually assumes that commanders will have a near real-time picture of enemy emitters, communications, and adaptations. The aircraft's influence extends into other designs and programs that may never carry the RC-135 name.
Concepts for newer intelligence, surveillance, and reconnaissance platforms, whether crewed or uncrewed, often borrow the idea of combining wide-area sensing with onboard analysts and robust communications. Future platforms inherit that lesson, whether they share the same outline or not.
For those who want to see the lineage up close, preserved members of the broader C-135 family appear at air museums and on-base flight lines as static displays. Some wear reconnaissance or test configurations that hint at Rivet Joint's relatives and predecessors.
In the end, the most important part of the Rivet Joint story is not the silhouette of the aircraft, but the crews who have spent long hours in its cabin. The aircraft stands as a reminder that behind every piece of hardware are people whose lives and careers turn on how well it performs.